All right, so chapter 17, number 22. We know that in this case, n is 200, p is 0.8, and q is 0.2. So in part A, they want us to find the mean and the standard deviation. So the mean is NP, which is 200 times 0.8, which is 160. Standard deviation is the square root of NPQ, which is the square root of 200 times 0.8 times 0.2, and that comes out to 5.66. In part B, they want to know, can we use a normal model? Well, if we can use it, is determined by the success-failure condition. And the success-failure condition says that NP must be at least 10 and NQ must be at least 10. Well, NP is 200 times 0.8, that's 160, so that's at least 10. And then NQ is 200 times 0.2, which is 40, so that's at least 10. So the answer is yes, since NP and NQ are both at least 10, it is okay to proceed with a normal model. Okay? So I'll use the 68, 95, 99.7 rule to describe this. And I'm just going to put this up on the page and show you what it looks like. You would create the normal model. Okay? And let me just zoom in on this. Alright, so there's your mean of 160. Then you add 5.66. That's one standard deviation. Add 5.66 again, and add 5.66 a third time. Then you start at 160. You subtract 5.66, you get 154.34. Subtract 5.66 again, you get 148.68. Subtract 5.66 again. So one standard deviation would be 68%. So 68% of all of the amount of arrows we expect a person to hit bullseyes on in 200 shots is between 154.34 and 165.66. That's what we expect to happen 68% of the time. 95% would be between 148.68 and 171.32, and 99.7% would be three standard deviations, 143.02 to 176.98. Huh? And then part E, it says, part D says, would you be surprised if she made only 140 bullseyes? Well, let's see. Let me zoom out again. There you go. D, I'm going to do a z-score for 140. So 140 minus 160 over 5.66. So 140 minus 160 divided, that's negative 20, divided by 5.66 is negative 3.53 standard deviations from the mean or less. So yes, we would be pretty surprised there if the person made less than 140 bullseyes, or she made only 140 bullseyes, because it's more, it's actually, I'm sorry, this is wrong. This is supposed to be the decimals in the wrong place. It's negative 3.53. It's more than 3 standard deviations from the mean, which is highly unlikely. Generally, anything over 2 standard deviations from the mean causes us to raise question about it. So this, we would be very surprised if this person made only 140 bullseyes out of 200 shots. And if they were capable of being 80% bullseyes every time that they shot.